Okay, hello and welcome to the virtual office hours. Hopefully you guys can hear me. If you can't hear me, please go ahead and type into your comment bar and I'll see what I can do, but I think everything should be working fine. What we're going to do today is go through the optional assignment number 3, and we'll see if you have any questions. I'll go through some of the stuff that's been posted on the message boards, and we'll answer some of the questions that are posted in the discussion forum in the virtual office hours, and then we'll go ahead and see if there are questions from the audience. There's a question from Sergey. Are these the first virtual office hours for cloud services, or did I miss any? This is the first one that I've done, and I'm assuming it's the first one, but Professor White might have done some earlier, although I'm not aware of it. Okay, so what I'd like to do to kind of kick things off is to go over and share my screen. Let's go find a screen to share. There's the screen to what we want to share, and let's go share it. There it is. Okay, so hopefully you can see this. So this is the screen I'll be showing. Let's go over here. There's a real nice posting from Ariel the other day, from yesterday in fact, and he kind of walked through a skeleton for doing assignment number 3. So first of all, of course, all the things we're going to talk about today are optional assignments. You can do them or not as you see fit. And as you'll see if you take a look at the descriptions, there's one that's done with ACE and there's one that's done with Java Netty. I'm a lot more familiar with ACE than I am with Netty, but you can pick and choose either one you want to do. You're also welcome to mix in as many C++11 features as you see fit. Keep in mind that C++11 has some really good support for things like threading, but and some synchronization mechanisms, but it doesn't really have any built-in support for networking. So ACE can be very useful there. ACE also has more of a sophisticated framework for being able to do things with concurrent network programming than C++11 does. But there's cool stuff you can do with C++11 for other parts of the solution. What you'll also see if you start experimenting between ACE and Netty is that Netty tends to have sort of higher level patterns. They provide you with more of the building block pieces already done for you. And whereas ACE gives you building blocks, so you can kind of decide what level you want to program at. Each one has its pros and cons, and what we're going to do first here is kind of talk about the ACE solution. So if you take a look at Ariel's posting, which is right here, it's called Reactive Web Server AC++ Assignment 3. He gives you the skeleton for it with some header files included. And down here you can see that the actual program is very simple. It'll be very simple in both Netty and ACE once you know how the framework behaves. And it certainly is a lot easier than trying to program at the socket level. If you watch the videos the optional videos that we put out for section 6, you'll see very quickly that a lot of the network programming mechanisms using sockets or p-threads have a tremendous amount of so-called accidental complexity. They're very low level, tedious, error-prone, non-portable, and so on. And so the various patterns and frameworks that ACE and Netty provide elevate the level of abstraction used to program this kind of software. So here's one of the abstractions that ACE provides as part of its acceptor connector framework. There's something called a service handler. And if you watch the video about this, you'll see that a service handler basically inherits from something called an event handler, and that allows it to be registered with an event demultiplexer called a reactor. And it's also then parameterizable by various kinds of IPC mechanisms. In this case, we're going to be using the ACE sock stream, which is basically a C++ wrapper around the low-level Unix sockets, or so-called BSD sockets. Not surprisingly, by the way, Java implements these kinds of things. These are called wrapper facades. Java has them in the form of its class libraries, things like the Java socket or socket server classes. ACE has sock stream, sock acceptor, sock connector, and so on. And those are just ways of encapsulating the tedious and error-prone mechanisms that are provided by the low-level network programming mechanisms. So if you watch the videos, it'll explain how that stuff works. So we make ourselves an echo service handler. Ariel went ahead and overrode the open method. You actually don't have to do that if you don't want to. You can just use the default one that comes out of the box with ACE, which out of the box goes ahead and registers the handler with the reactor, with the singleton reactor, the default reactor. So if you want to put some logging in, as this one does, for example, then you can override open and add your logging. If you don't want to put in the logging, then you can go ahead and just use what comes out of the box. So the only real method you have to implement in this particular approach is the handle input method. And there are various ways of doing this, by the way. You could do this with a service method if you were going to have multi-threads. You don't have to do that for this first assignment. That will be more useful with assignment number 4. For assignment number 3, all you have to do is you have to override the handle input hook method. You could ignore the parameter because it's already provided to you by the sock stream that you used to parameterize this particular class. And so what happens here is when handle input is called back, the reason it gets called back is because there was data on the socket that was created by the acceptor. The acceptor is basically a factory. We'll look at the acceptor in a second. And all you have to do in this case is you have to go ahead and read in the data. Now keep in mind when you're doing reactive programming, as we're showing here, you really can only do one receive per callback, because otherwise you'll end up potentially blocking other things from happening. So what you need to do is you need to receive the data, and now in this particular case it's pretty simple because you're just writing an echo service. So all you're trying to do is receive the data and then turn around and send it back to the client. So there's not a whole lot you have to do. But in a more sophisticated environment, like let's say you were trying to write a web server where you actually had to read in the entire request. In that case, if you were doing it entirely reactively, then you'd have to basically create an internal buffer that would be used to keep track of how much you'd read so far, and you'd have to keep getting called back by the reactor until you'd managed to read the entire message. In other words, until you reach the new line, or the carriage return new line. That's the end of the protocol in HTTP. So assuming everything goes right, you can read the data in, and then you can figure out how much data you've got. You might have gotten a -1, which means things have shut down. You might have gotten, it might have been an error. You might have got a 0, which means that the client closed the connection. If you get something other than a 0 or a -1, it means that you got data. And so what we do in this case is we go ahead and are going to send the data back to the client and see if everything worked. So that's basically what you're doing there. Very simple, basically just handling the input. Down here we define an acceptor. The acceptor is part of the acceptor connector pattern, or rather it's a framework, part of a framework that implements the acceptor connector pattern. As you can see here, an acceptor is a class that also inherits from event handler, so it can be registered with a reactor. Unlike a service handler, though, an acceptor is used as a factory for creating service handlers. So we're going to give it the echo service handler, which corresponds to what we did up here. Here's the echo service handler. So this is the guy that knows how to actually read the data. The acceptor is just a factory that knows how to accept connections, create service handlers, and activate them. And you can see here we use the sock acceptor, the ACE sock acceptor, with the acceptor, so that'll work nicely. And the echo service handler is the parameter that's used to create the handler for a connection that the acceptor accepts. Then we come down here into the main part of the program, and all we do here is basically just create an address object, which is going to listen on the port we want the server to listen on. Good port to listen on is, you know, port 8080 or port 200,002 or whatever you want. Then you go ahead and you create a reactor, you can use the default reactor, the one that comes with ACE, which is done through its so-called singleton reactor. And you would turn around and create your acceptor, and then you would go ahead and by the way, the way you can do this is that the acceptor by default will use the singleton reactor, so you can go ahead and use that, or you can pass in the reactor instance. So now that we've done that, this guy is now open for business. He's waiting for connections to come along from clients, and when a connection comes along, then the event loop, which is run by running the reactor event loop, will dispatch method callbacks on the acceptor, all of which are done for you, by the way. And then the acceptor will act as a factory. It'll accept a connection, create a service handler, which in this case is the echo service handler, and then activate it, which in this case involves calling its open hook method, which you either do yourself, or you just take the one that comes out of the box, and that'll end up registering the service handler with the reactor. And when data shows up, its handle input routine gets called back. And if you watch the videos, there's a whole bunch of sequence diagrams and interaction diagrams that show how all those things work. So we have a couple of questions here. Someone asked, why do we use ACE tmain instead of main? And that's a very good question. And the reason for doing this, of course, is because we want the, hold on a second, let me make sure I get my picture back here. It'll be a little finicky sometimes. Let's see, let me get that back up here. There we go. All right, the picture should be shared again for you. The reason we use tmain instead of main is because this will then work properly on both Windows and non-Windows platforms. That's also why we use this ACE tcare, and that's because Windows has different behavior for main than non-Windows platforms like Unix or variants of Unix like Linux and so on. And so by using ACE tmain, then this code will run trivially on both Windows and non-Windows platforms. So that's basically why we do that. And you'll see some of those weird things in ACE, and that's really just because of the craziness of portability between these different platforms. So that's essentially how the structure is of this assignment for the C++ version. As you can see, all you're really doing here is writing the business logic code that knows how to handle the data, which in this case is going to read it in and then just turn around and echo it back. All the other stuff is done for you out of the box by the reactor, by the acceptor connector framework, by the reactor, the wrapper facades, all that kind of good stuff. Okay, so that's basically an overview of that assignment. Let's see if there's any questions here. There's a question here about how to implement yourselves versus what to use out of the box if you use Netty. So as you can see in my response, you're welcome to do whatever you want. Netty gives you some pretty nice high-level abstractions that work out of the box to handle these kinds of things. So you can use some of the default features like a simple channel upstream handler and a channel pipeline factory and so on. And then if you're motivated, you can also drop down a little bit and work with some of the lower level stuff, which you can override and modify as you feel compelled to do, which will give you a bit more experience using the patterns and the framework capabilities that Netty provides. But you certainly don't have to do that if you don't want to. Let's see. Some people were having configuration issues, and there were some good responses on how to make things work. It's real easy to do. By the way, if you have questions about building or installing ACE, let me go show you where you can go. So if you go to, this is the ACE website, and if you go here, you will find information about developers forums. And if you go here, you'll see that there's a URL that's available through the main website. and it talks about the various mailing lists. There's also a news group as well, which is described here too. So if you're having problems with configuration, then I strongly suggest that you subscribe to the mailing list and then post your, or go to the news group. You can do it either way, and go ahead and post your questions there, because a lot more people who know ACE read that forum and can help you out. It shouldn't be hard to get it to work. I've never used Eclipse before, so I don't know whether it's easy or hard to use for C++. I always use either GNU Emacs on Linux with G++, which is kind of the old school way of doing things, or I use Visual Studio. Works fine with both. So that's some good places to go to find out more information. Another good question. In the lectures, there was a helper class called Reactor HTTP Server. Could we use it here? So yeah, let's go see if I can find the slides that show that, and I will display them, and we'll talk about that. You probably could do that. I'm not sure whether it's overkill or not. Probably not. Let's go find synchronous event handling, and we will go ahead and share the PowerPoint. There we go. Let's share the PowerPoint presentation, so we're all on the same page here in terms of what we're actually talking about. Oops, maybe it's called Reactor. Let's try HTTP server. There we go, Reactor HTTP server. This is what was being referenced, and here's the server. This looks like it probably will work quite nicely. Of course, you're not really doing HTTP, so you might want to change the name, but it's got the same basic idea here. This is just a little helper class that's parameterized by the type of acceptor you give it, and so you can go ahead and just pass in the command line arguments. It'll figure out what you need to get as far as the port number. You might want to change the default port number. It passes in a reactor, and it creates the appropriate port. In this case, again, it's not an HTTP port, it's the Echo server port you're using. But this is sort of a server in a box. It's one little thing. And you can see here's the main program that would use this. You would go ahead and create your Echo acceptor, Echo service acceptor, or whatever, and then you could go ahead and use this little helper class. Again, I would probably change it to be something a little different from Reactor HTTP server, but you get the gist of it. It's pretty straightforward how the whole thing works. So yeah, you could do that. Those slides are pretty helpful to give you an idea of what you might want to use. Let's see, let's go find. Here's the screen share again. So those are some things to think about in terms of how to build and use ACE. There were a bunch of other questions people asked here that relate to other parts of the course. So I'm gonna let that lie for Jules to address. He's the guru of Java-based web services. There's some more stuff here asking about how do you build ACE on different platforms. See if there's anything in here. So you might want to take a look. There's various tips on how to get stuff to build. It really isn't that hard to build as long as you stay with kind of conventional stuff. Some things, like I said, I've never really tried to use the Eclipse support, but should be straightforward. If you have any problems, go ahead and feel free to post it. All right, so that's really what I wanted to talk about today. Just wanted to give people a chance to ask any questions they had about the assignment. If anybody else has any other questions, please don't hesitate to ask. What we'll do is we'll probably do another virtual office hour next week, and I'll talk about assignment number 4 in more detail. Assignment number 4 is more complicated than assignment number 3. Assignment number 3 is just building a reactive server, which is really, really, really simple to implement. But the downside, as it's talked about at length in the videos, with a reactive approach, is you don't end up having the ability to run the requests concurrently. So if you had a long-running operation, which would be kind of strange if you're doing an echo service, but for a real server, doing things reactively would probably become a performance bottleneck very quickly, because you'd end up starving out a lot of other stuff. So what happens in that case is there are other alternative ways of structuring your solution. With ACE or with Netty, this is really, really simple. The videos give maybe a half-dozen different ways of structuring concurrency using thread per request or thread per connection or various thread pool approaches and so on and so forth. And assignment number 4 is just really doing a thread pool-like approach in order to be able to get things to run in a pool of threads. My particular implementation that I wrote does some really, really cool stuff with reactors to try to read the data in from the network without devoting a single thread that sits there and waits for the data to come in. So we'll go over that solution a little bit later. It's super cool. Probably more overkill than you might want to do, but it's pretty neat, and it illustrates how to do some very powerful things with reactors that go above and beyond what most people are aware of in terms of how reactors can be used. The basic idea with assignment 4 is you have a reactor at the bottom which is reading the data in a non-blocking way, and when it gets an entire chunk of data, then it goes ahead and uses an echo server to send it back. At least that's what you would do if you were using this for a real server. For an echo server, you can simplify it. And with the echo server for assignment 4, we basically prepend the thread ID to the information, to the data that's being echoed back to the client for a variety of reasons. It makes the assignment a little bit more interesting with respect to using various features like gather write operations, and it also allows you to be able to more easily debug what is going on in your solution. Let's see. So, question from Craig. Whoops. Hold on a second. Let me select these things so they don't disappear. There we go. Let's select Craig's question. So Craig's question was, more concerned about the capstone project because it seems like we'll have a lot of work to do in 5 weeks. So whether you may or may not know that there's a dry run practice for the capstone going on right now, and that's close to being wrapped up. And I think people have done a reasonably good job of being able to create the assignment in the 5 weeks. If you poke around on my GitHub account, you'll find the assignment description there, at least one of the assignment descriptions. We're probably going to have multiple assignment descriptions, but there's one we've been using as a prototype for the dry run. It's called the potlatch assignment. Let me go ahead and bring it up. I'll show you where it is if you want to play around with it. Let's see. Let's go bring up a browser so you can look at this thing. There we go. So if we go over here to GitHub, let's go to GitHub, and then we go to my directory on GitHub, and you can see we've got a bunch of things. We've got the repository with the assignments and the examples from the POSA MOOC. I'm teaching a new MOOC at Vanderbilt. Oh, not a MOOC. It's a class, not a MOOC. It's a real class, face-to-face class this semester, which is doing a bunch of cool stuff that builds upon and extends what we had done previously in the MOOC. And I've got a whole bunch of new examples that are available here if you want to poke around with any of that stuff. I'm also uploading all my videos to YouTube, so take a look there. I've been changing a lot of things based on my experience before. And then over here we have the requirements for the potlatch project. This is the project we're using in the dry run, just to kind of give people a feeling for how to do a project, and so you might take a look at that. So if you're curious and want to take a head start, you're welcome to take a look at the assignment that's described there. But I think so far it seems reasonable. We're still in discussions about whether we're going to extend the amount of time to make it a little bit longer. We're having a conversation with folks from Coursera tomorrow, and that'll be one of the topics for discussion. We'll see how that goes. I don't have a problem with extending it. The problem is it runs up against some holidays, which might be an issue for some people. Let's see. Some questions about NETI versioning. 3.6.9 should be fine. Actually, to be honest with you, I suspect the later versions probably work as well. I just was nervous about having people have a bunch of different versions, which would cause headaches with compatibility when we do the peer evaluation. So, to be safe, you might stick with the 3.6 series, and that will hopefully be a little easier. Here's a good question. If you want to read data until you get a new line, carriage return, or carriage return new line, where would you want to send it? That's a very, very, very good question. So to answer that question, let's go back over here. I'll reshare my slides again. Let's see if we can find this. So what you would probably do if you wanted to have data that was buffered in between calls. By the way, this is also illustrated, I think, in some of the slides for the class. What I would typically do in that case is I would add a data member to my Echo service handler, or more generally to my service handler. And what I would do is I would go ahead and I would put an ACE message block, or you can use any kind of buffer you want. I like to use ACE message blocks because they're real easy to chain together efficiently because of the way that they work internally. And my solution uses that, and I'll show that later. But basically what you would do is you would put an ACE message block or some other kind of buffer as a data member in your Echo service handler, and then you would read the data into that buffer, and you would keep basically either reading and extending the buffer, or if you use ACE message block, you can chain the various fragments together in the buffer, whatever you want to do. You keep doing this until you had the whole thing read in. And at that point, you would go ahead and if you use ACE message block, there's a way of being able to create a buffer out of all the various fragments that are read in. So that would be one way to do it. There's a bunch of different ways to do it. But yes, the answer to your question is the Echo service handler lives, it remains alive across callbacks to handle input. And the idea here, of course, is that that's what the reactor does. It keeps those event handlers or service handlers alive until you explicitly shut them down. And the videos explain how all of that stuff works. Let's see. Does ACE provide support for Windows named pipes? So the answer is yes. And if you take a look at the ACE S-pipe class, let's go see if we can find the ACE S-pipe class. That's where you would find that support. Let's see, we're going to have to share my, let's see, first off, to log in real quick. Whoops. If you go into ACE, and there's something called ACE S-pipe, I think, if I'm not mistaken, S-pipe, let's take a look at an S-pipe stream. I can't honestly remember exactly what this does, but I want to say that on Windows it uses named pipes. But we should go figure that out to make sure. There we go. Or it might just use sockets. It may not use named pipes. Yeah, I'm kind of getting the feeling that it doesn't use named pipes. It looks more like it's using sockets on Windows. So ACE may not have an encapsulation for named pipes. It's been a long time since I've looked at that part of the code, so I'm not really sure. Let's see. There's a question from Craig. If the project is any way like the Potlatch project, I assume you mean the capstone project, finishing the required 2 assignments, I'm concentrating on understanding and sketching out a Potlatch solution. Can you comment on this and the nature of the capstone project? So the way it's likely to work with the capstone, which is about 3 weeks away at this point, is we're probably going to have several projects you can choose from. One of which will be the Potlatch project or some variant of it. It'll probably stay more or less the same because it seems to have worked pretty well so far. And let's see if I can find some slides on the Potlatch project. That's another thing I could do. Trying to remember where I put all this stuff. Let's see. Let's share the PowerPoint. All right. Let me go see if I can find that. Okay. That's probably here under promos, capstone. There we go. Alrighty, very good. Now let's just go ahead and see if I can get this display to work, and we'll be in good shape. So you'll see when the project actually goes live, when the project goes live, we'll have a little video that'll talk about the thing and give you an introduction to it. So hopefully you can see it. So basically what you're going to do, at least for the Potlatch project, is you'll use Android and Spring, and you will develop a mobile cloud computing application. And here's what it looks like. Potlatch is basically a gift-giving ceremony practiced by the indigenous peoples of the Pacific Northwest. You can find out more about it. And basically what you do is you use it to take photos with your phone's camera, and you can go ahead and add a photo along with a title as well as some text to describe it. Those of you who read Black speak, if you're a Tolkien fan, you probably know what this says. And so you add the photo, and then you can go ahead and upload the photo to a server, which you'll write the server, and then you go ahead and can query through your phone, or actually you could use something besides your phone if you were so inclined, but in our case we're going to be using the Android phone. You can query for things like you might say, I want to find all pictures that are sunsets, and so it would download for you things that were sunset tagged, and then you could go ahead and indicate that you liked the photo. You could click on a little heart and say, I like this thing, or I was touched by this photo. And so that basically keeps track of it. So it's basically sort of a way to share photos with people who are part of your friend circle, and you can like them, and you can have things called gift chains. Each photo is called a gift, and you can have a gift chain, which is basically a sequence of photos that you put together and comment on. So that's basically kind of what's going to go on with the Potlatch project. There will hopefully be some other ones. We're in discussions with a few other groups about contributing other projects. Those are hopefully coming through soon. We'll see shortly if they bring it together. We might have another couple assignments that we give. But so that's basically what it's going to be like. So for those of you who've been doing all 3 MOOCs, which is what you need in order to be able to be qualified for the capstone, then the server side, the cloud service side, will look an awful lot like assignment number 2 from the mobile cloud computing course that Professor White is doing. And of course the part that's the mobile cloud, the mobile phone part, will look a lot like the kinds of things that you did in the previous MOOCs, Professor Porter's MOOC and the MOOC that I did. So you would end up having to be able to use activities or services, optionally content provider if you want to build a cache. That's not required. And you probably would also want to use the retrofit API, which is a really nice way of being able to create yourself RESTful APIs that you can call from clients in order to be able to access the content that's accessible through RESTful APIs implemented on the service. Can you put the Potlatch PowerPoint on your Git account? I'm going to wait until the assignment goes live because we're still likely to make a few changes to it. So I'm not going to put anything up yet. You just get a little preview. You can go. I mean, it's really very straightforward. I showed you the 3 slides I just showed you are the most important ones. Everything else is just sort of giving people some instructions on what to do in the dry run. When the other assignment, when the actual capstone starts, you'll get a similar video that will give you a similar set of instructions. But you basically saw what matters. You can take a look at the requirements if you want to see more about it. Okay, I think that's probably about it. If anybody has any other questions, I'm happy to talk about the capstone if you're curious about the capstone. I'm also happy to talk about the optional assignments if you're interested in that. I guess one thing I will do while seeing if anybody else wants to chime in with a few more questions. Let me go over here to show you. If you take a look at YouTube and you go to CS 282, this is the new semester's worth of stuff, and you'll recognize actually some of the stuff you won't recognize because a lot of this I created sort of new for the class. For example, there's now an overview of Android and the layers in Android with a focus on concurrency. There's an overview of the various Android components, so activities, services, content providers, intents, and broadcast receivers with a focus on concurrency. Then there's a bunch of stuff about concurrency, which is heavily revised and improved with more of a focus on Android, with lots of examples that are available in my GitHub account. So you can go there, and if you want to take a look at some of the stuff there, it's kind of different from what we covered in the MOOC. For example, some of the stuff I covered in the overview of Java threads, comparison and contrast the differences between user threads and daemon threads. So if you're interested in knowing those kinds of things, that's all covered there. Basically, there's going to be a lot more assignments, a lot more things that are available there. And I also have a set of assignments that are kind of fun. You can take a look if you go here and you go into this directory. I'm putting the assignments online as well. So the first assignment is a very simple map assignment. The second assignment, which is what the students are working on right now, basically has them implement a different version of the simple semaphore. I probably should have called, in retrospect, I should have called this the not so simple semaphore, because we're basically implementing something called the specific notification pattern in order to implement fair semaphores. So unlike the implementation that you did for the POSA MOOC, where we just basically used condition objects and reentrant locks to implement a fair semaphore, in the implementation that we're doing for the class, I'm actually having them use monitor objects, and they have to implement the queuing mechanism for the fairness themselves, which is much more complicated, as it turns out, than using a condition object and a reentrant lock. So you might want to take a look there if you want to play around with some other cool stuff. We've also got a really, really cool visualization for the Palantir Manager program that we did before, which is way cooler. Maybe I'll show it next time because it's so cool. Mitchell Gordon, who was the TA for the class, implemented this, and it's really neat. It visualizes beings gazing into Palantir using Android, and so we're having lots of fun kind of taking some of the assignments and sprucing them up a little bit, and so on and so forth. Let's see, there's another questions. Will our projects get exposure to industry experts, and will will there be help from industry experts? So that's a good question. So we're still kind of looking into that. We might or might not get help from the industry experts. If the companies that we're working with who are going to hopefully offer up projects in addition to the Potlatch project and anything else we dream up, if those come together by the time of the capstone, then those companies will provide feedback in the form of discussion forum postings and responses to questions and so on and so forth. We may also get a chance to have some help from industry experts. That's really more from the Coursera's side to arrange, and so hopefully that'll come together. We'll see. There definitely will get exposure. We've been talking with Google about ways of being able to take the best projects and then featuring them in the Google Play Store, as well as, of course, having a Hall of Fame that will be available to students in the class and anybody else on the Coursera site. It's called a gallery for people who want to be able to feature their applications. That's kind of on an opt-in basis. You're not required to do that, but if you'd like people to be able to see what you've done, that will be available to get exposure through Coursera and also hopefully through Google as well. I think that looks like it's pretty well settled. What's the next step after this specialization? Well, that's a good question. We're in discussions with Vanderbilt and also with Coursera about kind of redoing some of this stuff. If all goes according to plan, future specializations will be broken up into a larger number of smaller sections, which will leverage all the improvements that we've been doing to our material. So you could always retake some of that stuff, although it might be derivative if you've understood what we've covered. I don't know, honestly, what else there's going to be out there. That's a good question for Coursera. We're always looking to do more and different interesting things, but a lot of it comes down to resourcing and what's the business model to make this actually make sense for our taking time to be able to do these kinds of things. Let's see. Paolo, you're welcome. I'm glad that you like the open source approach to this. It's lots of fun to do. I always am amazed at the kinds of interesting feedback and input we get, especially when we're doing the course. One thing that always amazes me, honestly, is the difference between just putting videos up on YouTube versus having things part of a Coursera MOOC. I've been putting my class videos up on Coursera now, or sorry, on YouTube for a couple of years, and there's certainly people who watch them. Probably, several hundred people watch them over time. But when it goes up on Coursera, when we actually have a community of people who come together to work as a group, then all of a sudden there's a lot more interest, a lot more focus, a lot more interesting discussions. So it really demonstrates that people need an environment above and beyond just the videos in order to make something be a more effective learning environment. By the way, I should also point out that I'm having lots of fun. A lot of my friends on Facebook are professors, of course, and some of them are MOOC advocates, some of them are MOOC skeptics, some of them are MOOC haters, and it's always really funny to read postings from people who really have never taught a MOOC or really never taken an advanced MOOC, a MOOC where you're using sort of state-of-the-art teaching mechanisms like the Lightboard mechanisms that Jules White's using for his MOOC, or the auto-grading stuff that he's using, which is pretty cutting edge, or even honestly the peer grading stuff, or the Google Hangout stuff that we do in our virtual office hours. So a lot of people have a very narrow, backwards-looking view on what MOOCs are, which is always very amusing to me because I see it in a much different way. And so a lot of people keep saying, "Oh, MOOCs are done. This whole thing, it's a failure. It's a fiasco. They'll never make a difference," which in my mind is kind of like someone in 1975 saying, "Gosh, TCP/IP and this internet thing haven't completely displaced the telecom network. Therefore, the internet's a failure." Right? I can imagine people after a couple of years of internet protocol deciding that the internet was a horrible failure because it hadn't displaced the telephone companies yet. Well, obviously, over the period of 20 years, gosh, what happened? Gee, the telephone companies are being replaced by the internet, and we're doing everything over voice over IP. We're using things like Google Hangout and so on. So sometimes you have to give it a little bit of time for these things to come to fruition, to mature. The other thing I think is funny is people tend to think that MOOCs are very static and very non-interactive, and of course what we've shown through the use of Google Hangout and YouTube and the discussion forums is that they're very interactive. In fact, in many cases, they're probably more interactive than the kinds of things that we might want to do in our face-to-face courses, because students absolutely have to be engaged or they don't make any sense out of what's going on. whereas students in a more traditional class can show up to office hours and sort of hang out and absorb through osmosis the wisdom of the TAs or the teacher or the course staff. So I actually find that done right, MOOCs are much more engaging than even many of the face-to-face classes because people are so much more involved. And using all the new video technology and features like what we're doing here makes it really easy to keep interacting with each other. And that really seems to scale up quite nicely. Let's see. Do you cover concurrency models such as the ACCA toolkit of Scala in the non-MOOC class? No, we're focusing on Android and Java concurrency, not really doing anything above and beyond that. Where do I get more, let's see, another question. Where do I get more information about the Java aspects of the assignments? So I'm not quite sure what you mean, Mary Kay. All the assignments, you can download the assignments on my GitHub. Some of the assignments are just Java using Eclipse, so there's no particular difference, no particular variation from what we did in the POSA MOOC. Other assignments are Android, so of course you would use those, and in both cases all you have to do is just import them as Java projects if they're Java code, or Android projects if they're Android code, and just go to town, so there's nothing really to do. As you probably know, there's also many videos describing the Java portions of Android, so if you want to learn about Java concurrency, then there's lots of videos that I have from the POSA MOOC that you can watch that are available on YouTube or available through the Coursera interface if you want that form. I'm also recording new videos with more examples as part of my CS 282 course, so you're welcome to take a look at those too if you'd like. But all that stuff is all available. So if you have other questions, I'm not quite sure what you mean, but feel free to either ask them now, we have a few more minutes, or feel free to post the questions on the virtual office hours discussion forum if you'd like to do that. Okay, any other questions, any other comments? Well, thanks very much for taking the time to be here today. I will go ahead and produce a video from this virtual office hours and post it to the class like we always do. And in the meantime, if you have any questions, we'll make another space in the discussion forum for more virtual office hours Q&A, and I will have them for the next time. All right, well, thanks a lot, and I will see you later.